Hello friends, in our last video we saw how to program a vehicle using Arduino commands. In this video we will make one program to operate vehicle using Arduino commands. For that, first let's understand the requirements. So the requirements are the vehicle has to start moving from point A, reach point B, take a U-turn, come back to point A, take a U-turn and stop. Let's write down these steps. We need to start vehicle at point A. Then move forward to point B. When it reaches point B, take a U-turn. From point B, it should move forward to point A. When it reaches point A, it should again take a U-turn. And then stop. So these are the steps which we want to take. So let's program each step. So to start the vehicle, what we need first is to ensure that pins are set with the correct mode. So which pins? Pin number 2, 3, 5 for left motor, pin number 4, 7, 6 for right motor. Since they are motor pins, that means they are output pins because motor is a output device. So let's set the mode of the pin to output. This is a command pin mode which has two parameters, pin number and the mode. Pin numbers we know and mode we know. For all of these pins it is output. So I'm going to copy this and repeat this total 6 times. And change the pin numbers. So pin number 2, 3, 5 for left motor. Four, 7, 6 for right motor. So we have set up the mode and now we should start the vehicle to move in a forward fashion. So we have to move forward. We have taken care of this. For moving forward, we know the left wheel has to move anti-clockwise and right clockwise. Let's first talk about left wheel, anti-clockwise. Left wheel has 3 pins, 2, 3, 5. 2 and 3 decide the direction. If 2 is low and 3 is high, it is anti-clockwise. Direction is a digital value. Hence, the command we use is digital right. Because we want anti-clockwise, pin number 2 is low. Pin number 3 is high. This will ensure that left motor rotates anti-clockwise. Now the speed. Speed is an analog value. Hence the command we use is analog right. Pin number 5 and speed we want to give 255. So that ensures that left motor moves anti-clockwise. For moving forward, right motor should move clockwise. Clockwise means the first pin, which is pin number 4, has to be high. And again digital right because it is direction which we are setting. And 7 low. That will ensure that motor right moves in clockwise fashion and the speed is the analog value. To 55. So this set of 6 commands will start moving vehicle forward and we have to reach point B. So we have to keep on moving forward and at point B we will take a turn. So the next action is happening at point B. So till that time we need to have delay. let's give 2 seconds delay, that is 2000 milliseconds. So this means we have done this, we have reached point B. Now we want to take a U-turn at point B. Let me first copy these commands and make necessary changes to this command to effect U-turn. Now we want to take a U-turn, we want to take hard turn. Let's assume that I want to take hard right turn. For hard right turn, the right motor should move backwards and left should move forward. Here, these commands are moving the left wheel forward. That is perfect, so we don't want to change them. And these commands are moving right wheel forward, but we don't want right wheel forward now. We want right wheel backward, which means it should change the direction. And this is what is going to decide direction. It was high-low, now we made low-high. That will ensure that right motor moves anti-clockwise, which is backwards for right motor. So right motor is moving backwards, the left motor is moving forward. That will ensure that it takes a hard right turn. But hard right turn also needs a specific amount of time. So these commands need to execute a little longer before the next action starts. And for that we need a delay. With our experience, we know that delay of 650 milliseconds are sufficient for 180-degree turn. So I've given that, but when you upload program, when you try program for your battery voltage, for your motors, this might change. You need to check whether your vehicle is turning 180 degree. If it is turning less, increase the delay. If it is turning more, reduce the delay. That means we have taken care of this point. Now these 2 points are repetition because we have to again move forward and take a U-turn. So these 2 points are repetition, which means we have to just copy paste this. So this will move forward for 2 seconds from point B to A now, and at point A it will take a U-turn. So we have taken care of these 2. And now finally stop vehicle. I will copy this and make necessary changes to ensure that we stop the vehicle. What do we need to do to stop a vehicle? We need to apply brakes and we need to take out our feet from the accelerator, which means we need to make speed 0 and apply brake. That means we need to remove the energy from the motor, and to remove the energy we need to remove the current. To remove the current we need to apply the same polarity to both the pins. So I'm going to use both low. That will ensure there will not be any current flow and hence motors will stop rotating. And this will ensure that we have stopped the vehicle. So this completes our program for taking vehicle from point 1 to point 2, take a U-turn, come back to point 1, take a U-turn and stop. You can upload the program and try it. You might need to change this delay time to ensure that your vehicle turns exact 180 degree.